Okay, picking up exactly where we left off. There's really just a little bit left to do, because luckily for us, or rather this SEM tools package that we can install and use. I'm going to go ahead and use the library right now by running that line. Gives us this cool little function called measurement invariance, which basically just runs all of your invariance tests at one time. So yeah, measurement invariance using that CFA1 model that we built at the very beginning, looking at the entire data set. This is kind of interesting, I thought, because we divided the data set up here, but we don't need to use those divided data sets because measurement invariance can let us look at our full data set and then just choose a grouping variable. So it's going to group it for us when we tell it that we want to group it by sex. And then this line here is strict equals false. If you wanted to include an extra model, and again, I have this explained in the comments, but you could, if you made strict equal true, it would include another model that it would run that would actually have it up here. It would include this kind of in the middle fourth model. As we have it now, as with it false, it's going to run four models, but it's not going to run this strict invariance model, which also constrains residual variances. Yeah, so we're not going to run that, but that's an option that you have. So I just left the argument up there in case someone wanted to run a model that did restrict residual variances. Now they know how. Cool. I'm going to go ahead and run this model, or run all of these invariance tests. It's not really a model. Or maybe it's four models. Yeah. Cool. So it's going to spit out some stuff. And you'll see that it runs four tests, four models. Configural, that's just kind of like your baseline model, where only the factor structures are similar. One second, my notes have disappeared since I've gone back to recording. So yeah, that's going to be basically your baseline model, and then it's going to run a model that constrains the loadings, and that's basically going to be a test of metric invariance. Then you're going to constrain the intercepts, and at that point, it's a scalar test of scalar invariance, and then the last one is a test of equal factors by constraining the means. And I guess I should mention, this is pretty important, that it's hierarchical. So when I say that this is constraining means, it's constraining means, intercepts, loadings, and it's configurable too. And then the intercepts is constraining intercepts and loadings, so they build on top of each other in terms of what they're constraining. And so we have these chi-square tests. These are tests of badness of fit. So if it's significant, if it's insignificant, that means they're basically the same amount of fit. So we should go to it with the one that is later on in the series. So what's happening is model one, the configurable model is made, and then that is compared with the chi-square distribution to the loadings constrained model. And that was an insignificant chi-square, so basically saying that it's okay to accept this level of invariance. There was no invariance in terms metric invariance because this chi-square was not significant. But when we run into constraining the intercepts for scalar invariance, it seems like there might be a problem with scalar invariance between the two groups because the chi-square is significant. So this model was significantly worse than the previous model. And you can see they have the chi-square scores for the current model, and then the differences between it and the last model. And same for, oh wait, yeah. So that's listed here. Yeah, I'm jumping ahead of myself, but fit measures. Then finally, for each model, they give you the fit measures, CFI and RIMSI, and then this is kind of I guess that's true up here too. This is basically the difference between this model and the last model for chi-square, and you can figure that out because it's just doing maths here. But this is a similar thing. It's just for fit statistics. So you got your CFI and your RIMSIs, and then the change between the last models. And again, you could add it here, but it's just giving you your deltas. So you don't have to do all the math between these. And that's pretty much it. I did a little bit of interpretation while we're going along there, but basically CFA and R is just spitting out numbers to you, and it's up to you to figure out what's going on out in the literature to try to interpret those numbers, to see if you're finding the fit, good fit for your model. But yeah, R gives you a lot of good options to or a lot of good indices. It calculates those indices for you, so that's nice. And the fact that you can run all of these measurement invariance tests at the same time with this function is also pretty nice. So hopefully that was helpful to you. And I'll see you next time.